Dear students, in this video we will be discussing from question number 9 of chapter 1. Question number 9 is what does one mean by exothermic and endothermic reactions? Give examples. So we know that exothermic reactions are those in which heat is released, while endothermic reactions are those chemical reactions in which heat is absorbed. So some examples of exothermic reactions are burning of coal, burning of methane gas, etc. So we can find the examples in page number 7. Here, this burning of coal is an example of here when coal is burned, carbon reacts with oxygen to form carbon dioxide gas and a lot of heat energy is released. Similarly, burning of natural gas is an example of exothermic reaction. The chief constituent of natural gas is methane. So when methane is burnt in air, it combines with oxygen to form carbon dioxide, water vapor, and energy. So these are examples of exothermic reactions. Now let us look at examples of endothermic reactions. In page number 9, we can find that when silver chloride, white color silver chloride is left under the sunlight, it turns gray. So we have learned before that this is a kind of decomposition reaction, the equation for which is this one, decomposition due to sunlight. So here we can see this is an example of endothermic reaction as well as decomposition reaction. So when silver chloride is left under sunlight, the silver chloride, this compound, absorbs the sunlight energy, and by absorbing the solar energy, this compound breaks down to form silver and chlorine gas. So this is an example of endothermic reaction. As long as the solar energy is absorbed by the compound, the decomposition reaction will be taking place. So this is an example of endothermic reaction. Similarly, other endothermic reactions are shown here. So here is another one, that limestone upon heating, it breaks down to form quicklime and carbon dioxide. So this is also kind of endothermic reaction, because for breaking down this compound, this constantly heat energy has to be supplied, and because of that heat energy that is absorbed by this compound, the chemical bonds are broken and new bonds are formed to form these compounds, that is calcium oxide or quicklime and carbon dioxide. So this is another example of endothermic reaction. Let us look at the next question, question number 10. Question number 10 is, why is respiration considered an exothermic reaction? Explain. So we all know that respiration is a process during which glucose is oxidized in our cells to release energy. So it is an exothermic reaction. So the energy that is released during the process of respiration is used not only for doing physical activity or in metabolic activities in the body, but also this energy that is released during respiration helps in maintaining the body temperature. So thus respiration, since in respiration energy is released, therefore respiration is an exothermic reaction. So for the equation we can turn to page number 7. So in page number 7 it is mentioned here that, do you know that respiration is an exothermic process? So here it is given, these carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body during the process of respiration and provides energy. Therefore, this respiration is a exothermic reaction. The equation for respiration is C6H12O6, that is glucose, plus oxygen produces carbon dioxide, water, and energy. So we come to know that respiration is an exothermic reaction. Next, question number 11 is, why are decomposition reactions called the opposite of combination reactions? Write equations for these reactions. That means we are asked to give one example for each. So as the name suggests, decomposition means breakdown, while combination means combining of substance together. So we can state directly that in decomposition reactions, a single reactant breaks down to form two or more simple products, while in combination reactions, two or more simple reactants combine to form a single product. And so decomposition reactions are called the opposite of combination reactions. After that, we can give any one example of decomposition reaction and that of combination reaction. Let us look at the examples. So you see, these are the so many examples of decomposition reactions. Decomposition due to heat, that is breaking down of calcium carbonate, a single reactant to form calcium oxide and carbon dioxide. Another example is when electricity is passed through water, which is a liquid. The water molecules break down to form two products, hydrogen gas and oxygen gas. So this is also an example of decomposition reaction. Okay, then silver chloride, when left under sunlight, undergoes decomposition reaction to form silver and chlorine. So these are the examples of decomposition reaction. Now let us look at examples of combination reactions. I will show you 3 of the combination reactions from our book. Here, the very first reaction we had got earlier is the burning of magnesium ribbon. No? When magnesium is burned in air, it combines with oxygen to form a magnesium oxide. So this is an example of combination reaction. Then the next example is in page number 6. It is there. When calcium oxide or quicklime is put in water, or it is mixed with water, it reacts vigorously with water to form slaked lime. That is calcium hydroxide. So this is also an example of combination reaction when calcium oxide and water are combining together to form calcium hydroxide, a single product. Similarly, another example is the burning of coal. So when coal is burned in air, the carbon present in the coal combines with oxygen to form carbon dioxide gas. So here the reaction of carbon with oxygen to form carbon dioxide is an example of combination reaction. Okay. So question number 11 is clear. Now let us turn to the next page, page number 16, question number 12. Question number 12 is write one equation each for decomposition reactions where energy is supplied in the form of heat, light and electricity or electricity. So this answer, this is the answer which we have seen a little while ago. So how we can write the answer? 3 examples of decomposition reaction where energy is supplied in the as heat, electricity and light are. So you have to, it is good to give the headings first, then give the example. So first you write decomposition due to heat, then you write this example, calcium carbonate on heating breaks down to form calcium oxide and carbon dioxide. Next example is decomposition due to electricity. So when water, when electricity is passed through it breaks down to form hydrogen and oxygen. So you have to provide balanced chemical equations. Okay. Next is decomposition due to sunlight. So when silver chloride is left under sunlight, it decomposes to form silver and chlorine. The white color silver chloride turns gray. So these are the 3 examples that we have to write as an answer for this question. Our next question is question number 13. Question is, what is the difference between displacement and a double displacement reactions? Write equations for these reactions. So we have already discussed this part. So the basic difference is that in a displacement reaction, a reactive element displaces a less reactive element than itself from the compound in solution. But in double displacement reaction, there is an exchange of ions between 2 compounds in the reaction to give the corresponding products. So here in a simple displacement of ion takes place from a single reactant. A less reactive element is replaced by a more reactive element. But in double displacement reaction, there is a displacement taking place in 2 compounds at the same time. So we'll look at the examples which will make it clear. So we have learned earlier that what is a displacement reaction. In a displacement reaction, a more reactive element displaces a less reactive element than itself from the solution of the compound of the less reactive element. So the very popular reaction is this one, that when iron nails are put in a solution of copper sulfate, gradually the copper sulfate solution turns green. Gradually the blue color of copper sulfate fades away and eventually it can turn green. So why? So this is the example for the displacement reaction. First you need to write the definition and then this example. So example, iron plus copper sulfate solution produces iron sulfate plus copper. So you see here, iron is a more reactive element. Iron is a more reactive metal than copper. So it is when iron is placed in a copper sulfate solution, the iron is able to displace the copper from the solution and itself goes into the solution to form iron sulfate, while the copper settles down as a solid. Okay, so this is the example of a displacement reaction. There are other examples also, like zinc reacts with copper sulfate to produce zinc sulfate and copper. Lead reacts with copper chloride to form lead chloride and copper. It is enough to mention one example in the answer when you write it. Okay, so concept is always a more reactive element only can displace a less reactive element from the solution of its salt. Okay, now in a double displacement reaction, what happens? There is an exchange of ions between two compounds. A chemical reaction where there is an exchange of ions between two compounds is called a double displacement reaction. So example is when a solution of sodium sulfate is allowed to react with a solution of barium chloride, then barium sulfate and sodium chloride is formed. A white precipitate of barium sulfate is formed. So this is an example of double displacement reaction, as it is clearly evident from here that sodium sulfate it reacts with barium chloride. Here there is an exchange of ions. The sodium sulfate comes here, and the chloride goes there, resulting in the formation of sodium chloride and barium sulfate. So you can see here, so this is an example of double displacement reaction. The answers are already provided in our app, so I hope you have understood these answers. In our next video, we'll discuss the remaining question answers. Thank you.